Okay, so the lesson due Thursday, April 23rd, is called Exponential Expressions, which is strange to me because it's really about the equation. And there's going to be 3 videos that you can watch in 2 practice sets. Again, I feel like if I do my videos and you're really watching my videos, you're taking notes, then you should be able to just go to the practice sets as long as you have your notes in front of you. And if you look at these examples, they're really annoying to write down. So maybe if you just take general notes on the examples or like take the important parts from each problem, that could help. Okay. So here's your general equation of an exponential function, and the unknown, or our x, is going to be in the exponent, which is why it's called an exponential function. So let's talk about what b stands for. And I like to use, a lot of people use ab or ba to the power of x, but I like these because they relate back, and we can call them kind of the same things that we called them for our linear equations. And I like to make connections because that helps us learn. So b in our y equals mx plus b, so I could just write that for reference. B was our y-intercept. Okay. True. We also called it our starting value. And we're getting pretty sophisticated. We can also call it our initial value. So you'll hear kind of all these buzzwords on Khan Academy, and then when you get into Algebra 3-4. M, we called M our slope over here. We don't really have a slope for exponential functions. I like to call it growth, which was slope or growth. For linear equations, it's what was added every time, right? We would go over and then up 3, or go over 2 and up 3. That was the growth of the equation in terms of adding. For here, we can also call it the multiplier. And the big mathy word is the common ratio. All right, so for our example, I'm going to talk about the equation 3 times 2 to the x. Okay, so 3 is our initial value, or our starting value. So just to connect it to the top, that's our starting value. I can use any of these words to describe it. And 2, let's just call it our multiplier for right now. It is our growth, and it is our common ratio. Let's look at the table. So x and y, except we're calling it our fancy y, which is f of x. And I'm actually going to start with -1, and we'll just go to 2. 0, 1, and 2. All right, let's start with 0. So I just said that 3 is our starting value, or the y-intercept. So this should be 3. And let's see. So if I say 3 times 2 to the power of 0, anything to the power of 0 is 1. So 3 times 1 is 3. So that's good. Let's plug in 1. So 3 times 2 to the power of 1. Anything times 1 is to the power of 1 is itself. So that's just 6. And let's square it. So 3 times 2 to the power of 2. And this is PEMDAS. I do exponents first, or parentheses first, because of PEMDAS. Parentheses and exponents come before multiplying. So do not do 6 and then raise it. You've got to do these exponents first. The order of PEMDAS never changes. So that's 3 to the 4, which is 12. So the reason why I wanted to call it a multiplier is because if you look at this, we are multiplying by 2. And we do it again. So if I see this pattern, so in a linear equation, we were adding all the time. In an exponential equation, we're multiplying. So this should be 24. And I'm not going to check that because I'm not going to take that time. Well, let's go backwards. What's the opposite of multiply? Divide. Right. So if I divide by 2, I divide by 2, I divide by 2, well, that should be 3 divided by 2, or 3 halves, which is 1.5. Let's look at that. So I'm sorry, this is getting a little cluttered. But I'll work it out over here. So 3 times 2 to the negative 1. So I have to do this first. So let's make that a positive 1. So if I want to make that positive, I bring it to the bottom. Oh, look at that. Anything raised to the power of 1 is just itself. Okay. So that's just an example of an exponential equation. Down here, I want to talk about percent growth. And I think this is where math gets fun, is the real world stuff. This is about credit cards and buying homes and cars and things that have an interest or a value. So B is the same thing here. So this is when you're given a percent growth. So B is still the starting value or initial value. And then R is going to be our rate. And it's going to be a percent as a decimal. And a lot of teachers will tell you how to move the decimal points to the left or to the right 2 spaces if you're going from decimals to percents or percents to decimals. And the word percent means literally per 100. So if you're ever given a percent and you have to figure out the decimal, the easiest for me is just to divide by 100. And then if we decrease in value, we just take that percent away. So the 1, I'm going to put what the 1 stands for. The 1 stands for 100%. And again, that's 1. 1 is 100% as a decimal. So we're talking about some starting value, and we take 100% of it, and we add something every year, or every week, or every month. Or we take something and we take away every year, or week, or month. Okay? So let's give one example, quick example here. Let's say I have a bank account with $3,000 and it's going to grow. Okay, so bank with $3,000 grows 5% each year. So it'll be some time. So first I have to put 5% as a decimal. So if I do 5 divided by 100, my calculator is going to come back with 0.05. And these are like the biggest mistakes I see is when they're just the 1 numbers and having that 0 in front of it. Okay, and so that'll be the years. X is the number of years, and f of x is the money in the bank account. So you'll see this in Khan Academy as 2 different ways. I will always put this in like this, and Khan Academy will count this as right. But a lot of times you'll see them just combine what's in this parenthesis as 1.05 to the power of x. So you could say 1.05 is the multiplier. You might see that in Khan Academy. Or they're going to say a 5% increase. And they mean the same thing because we took 100% and we added 5%, so it's a 5% increase. Or we can also just call it one number and call it the multiplier. All right, let's go through these 3 examples. Let me see if I can zoom in a little bit. All right, the per capita gross domestic product of Australia was this much money. So here's your initial value right there. Afterwards, it increased by approximately 6.7%. So it says write a function. So 1800 is my B, or my initial value. And since it's a percent, I'm going to go to that second equation, and that's R. So I have to change that. That, even though it is a decimal, guys, that's still a percent because that percent sign was attached to it. So I divide it by 100, and my calculator will come back as 0.067. So here, you can type it in the box, but I'm going to say my starting value. So it's going to look like this. Sorry, it's going to look like this one in my notes. Times the quantity, 1 plus, because it increased, by my percentage as a decimal to the power of x. So that's what goes in here. Let's go to the next one. On a day that a certain celebrity gets married, 10 people knows about it. So 10 is my B. That's what happens right away. That's the initial value. Each day the number triples. Oh, so your multiplier, triple means times 3. So write a function. Well, this one does not use a percent, so I feel like it's better. So B goes first. So this is going to look like this one right here. And then my multiplier is 3 to the power of, oh yeah, I got these wrong. You have to put T. You have to put T. So sorry, put T. They say T here, T years, T. Okay, don't forget the T. Sorry. All right, so you'll see those, and then let's do these down here. Let me back this up. Okay, so this is the expression. And it models the US dollar. So I could so they're asking about this. And just like my notes, I think I did the same exact one. Sorry about that. So that's going to be called the multiplier. So doubled no, we don't see anything about doubling. There's no rule about doubling. The average wage, nope. Oh, the US increases by about 5% every year. Well, remember, this could be 1 plus some number. And that gives you the same answer as your 1.05. And so this as a percent, if we wanted to go backwards, we would multiply by 100, is 5. So the average wage increases by 5% each year. That's this one. Okay, last one. Sorry, I'm trying to make this. So the expression 900 times 2.25 to the power of t gives the price performance in bits per dollar of the wireless device of a certain company as a function of years. What does 900 represent? So 900 is that first one. So we're looking at the word initial or start or, initial. Okay, the company will have 900 years after begin. No. The initial price, I think it's this one. Initial. And this one says the price efficiency is multiplied, so it's not the multiplier. No, thank you. So that's your answer. So one video, exponential expressions. You've got 3 videos and 2 practice sets.